In this lesson, we'll get acquainted with a reverse engineering approach that uses KOMPAS-3D for precise modeling based on scanned data. An approach to reverse engineering using KOMPAS-3D contains 3 steps. The first step includes 3D scanning and data processing. A 3D scanner takes measurements of a physical object to digitally capture its shape. The scanner initially outputs the data as a point cloud, a collection of individual points in 3D space that represent the object's surface. The raw scan data is then cleaned, with erroneous points removed and surface imperfections corrected. In most cases, 3D scanners designed for mechanical engineering include scanning software that processes the point cloud data to generate a mesh. The second step is modeling precise geometry in KOMPAS-3D based on the mesh. You can use standard solid sheet metal, wireframe and surfaces modeling commands for this. The third step involves production using various methods, for example casting, 3D printing or CNC machining. In this course, we'll explore the second step and create the impeller model based on its 3D scan. Let's run through the KOMPAS tools we'll use for modeling. We'll begin with the possibility of reading different formats such as STL, JT, OBJ. After importing such models, KOMPAS-3D converts them into polygonal objects. Polygonal objects in KOMPAS-3D are represented as triangular meshes. These objects are used to describe the surfaces of 3D objects with high accuracy while requiring minimal computational resources. The options for working with polygonal objects are limited. Polygonal objects cannot be edited and are not transferred to drawings. However, you can take measurements between vertices of the polygonal model and snap to the vertices while creating new geometry. Also, you can convert the polygonal model into precise geometry, resulting in an operation without history. You can create a curve of intersection between an imported mesh model and a plane. Of course, this curve will contain a large number of segments and won't be suitable for correct modeling. However, you can create a proper contour based on the intersection line and use it for creating a revolution element, for example. The surface adjustment command allows you to generate parametric surfaces by approximating selected regions of a mesh model. Then you can connect the surfaces and transform them into a solid body. The deviation analysis tool can be useful if you need to evaluate the deviation in geometry between a scanned model and a reverse engineered model. The result of the deviation analysis is displayed as a color map.